we'll start the chapter number 1. Actually, there are 9 chapters in this book, and in a single semester, 6 chapters will be enough. Thus, we'll start the introduction, chapter number 1. Okay, this is the computer networking, a top-down approach, 7th edition, and that is published by this Pearson company, and the authors are Cruz and Ross. Okay, let's move to the next. Here we learn about the introduction, and this one is explaining briefly the whole concept of the computer networking, and here we learn about our goal in this chapter, and the brief overview here. Our goal is to get some feeling, and we will learn about some terminology about the computer networking in more depth, in more detail later in this course. And we will use internet as a very useful example, because every day we are using this internet, and actually that is the outcome of this computer network evolution. We are using that fruit as a result of this computer network. What is the internet? We learn, and what's the protocol, and the new network edge, and some host concept, and access network, and the physical media. We learn about them. And in the network core part, we learn about packet switching concept and the circuit switching concept, and after that we learn about internet structure. And in terms of the performance of the computer network or internet, we should understand the performance metric. Those are loss and the delay, that is the time, how long does it take, and some speed, throughput here. And in this chapter number 1, a brief overview about security that will be discussed briefly, but the main topic in this book, probably in the chapter 8, that is discussed. Thus later you can refer to that chapter 8, that is security in computer network. And after that we'll briefly look at the concept of the protocol layers and the service models, and we learn about some history of the evolution of this internet and the computer network technology. Let's move to the next. This is the sub-chapters in this chapter number 1. What is the internet? We learn about this sub-chapter first. This is a view in terms of the components, nuts and bolts. Internet is composed of these components. We are using PCs and the notebook, laptop computer, and the servers, and smartphone, and all of them, those are connected to the internet, as we know. Billions of connected computing devices. It's much more than that, because that number is still being increased rapidly. If we are considering even the Internet of Things, IoT devices, then the number of the devices are increasing rapidly. And here we learn about this terminology, host. This terminology, this term means end system. End system means PC, server, wireless laptop, smartphone. Those are all hosts. And in this end system, in this host, network application that program is learning. And if we are looking into the network a little more, then you can see the communication links. Even though there is no link, wireless link, wired link, and wired link here, we can see here wireless link. Those are all communication links. And there may be many different media like fiber optics or copper line or radio and the satellite. In terms of the speed, performance, the bandwidth is important. If we are using the service, then bandwidth is important to pay the subscription fee. Depending upon that bandwidth, that may be different. And this service provider is billing depending upon that bandwidth also. Those performance metric is important. We learn about them later. Here, this is a mobile network, and inside of this infrastructure, we can see this is global internet service provider. And if we are considering our home, then that is called home network. Think about your apartment or house. Here you can see this one. This one is the symbol of the router. We learn about this later. The internal component that is being used to interconnect. Here we can see this is institutional network, like our university academic network, university network, that is called institutional network. This is called packet switches, especially this one is called router. We can see different devices later, even though that is not described well enough here. The switch that is also important, Ethernet switch, the Ethernet switch that will be used to interconnect these devices to the router to transfer to the other side. This one is forwarding the packet. The packet is called the chunks of data. We learn about this concept packet later. And now at this moment, this is a portion of data, chunks of data that will be transferred separately through these internet router devices. This is some example showing some applications depending upon the today's weather forecasting. Toaster is cooking. Okay, this one is internet protocol picture frame. At this moment, this is so simple application. We can use the internet, and the screen is on this refrigerator. And this is the set-top box to watch TV. This one is sensorized bed mattress and Internet of Things. That kind of application will be possible, even though that is not well described here. And internet phones, those are becoming so popular at this moment, but long time ago, those are all new devices using internet technology. Also, this one is monitoring of that energy consumption, smart energy technology, a kind of smart energy technology. And the remote side, that consumption of that electricity that will be reported and billed depending upon that consumption of that electricity. What is the internet? Still we are learning about that components. Internet, in other words, that is a kind of network of networks. Here, inter means between network. Between network means there are different heterogeneous network. We need to glue them together. Internet protocol is doing that. And finally, we can see single view of the internet, but inside there may be many different heterogeneous networks. Internet technology, that is connecting them together tightly. We learn about them. This is called interconnected internet service provider. Here, different internet service providers. They are servicing this internet service provider. Each one is providing that service to its customer, and another internet service provider is also providing that service to its own customer, and their devices are interconnected. depending upon that internet protocol, internet technology. They are tightly connected. And here we need protocols. The protocol is doing that, controls and receiving of messages. We need some standards. In terms of this protocol, TCP is one of them, and as you probably hear many times, Internet Protocol, IP, all of them, those are protocols. HTTP, every day you are using Internet, and every day probably you are using this protocol. Hypertext Transfer Protocol, we'll learn them later. Also, this Skype, this is a name of a company or name of the protocol. This one is 802.11, A, B, T, N, and so on. This is called, in other words, Wi-Fi, wireless LAN. We need some internet standards because in the world there may be many different networks. We need to hook up them together based on these standards. Thus, in the communication field, standard is very important. Request for comments. This acronym means request for comments when we are making some standards. Depending upon that RFC number, that will be followed, that will be standardized, and some standard activity by many working groups that will be completed finally. And we are using that final result. Also, this is another standard body. Like other many standard bodies, IEEE and ISO, International Standard Organization, and also in terms of this internet technology, this IETF have done very important work and standard activities. The full name is Internet Engineering Task Force. This is a kind of standard body. Okay, let's move to the next. In terms of the service view, the internet is an infrastructure that provides services to applications. For example, web service, voice over IP service, email service, game, e-commerce, social network, fintech, blockchain. Many things, many new coming services are based on this internet technology. For example, internet and the Internet of Things, cloud, big data, artificial intelligence, mobile, blockchain, fintech, social networking service, online to offline, virtual reality, augmented reality, online game, and so on. So many new interesting technology and the services are based on this fundamental technology. That is internet technology. That is computer networking technology. And in terms of the service view, internet is providing programming interface to application. This one is enabling the hooking. Thus, it hooks that allow sending and receiving application programs to connect to internet. Networking software, depending upon that protocol, internet application program interface. We learn about this program interface, API, for example, socket programming, API later, briefly. We learn about them. And provide service options. This one is analogous to postal service. If we are considering some analogous example to understand better and simpler when we are trying to understand the internet technology, how it is working. Think about postal service. When you are sending some mail to other household, then that mail should be transferred through that postal system. That postal system, that is a kind of internet infrastructure. And we learn about that analogous example later also. Okay, let's move to the next. What is a protocol? This chapter number 1. This one is introduction chapter, thus this one is briefly introducing many small and important concepts and terminology, briefly. And also some analogous example. For example, what is a protocol in terms of the human protocols as an analogous example? Think about this case. What is the time? You are asking to a person, then he or she may answer about that question. Or you can ask to know the current time. I have a question. What is the time? And you are introducing yourself. There's some method. This is based on some human method, human etiquette, human protocols. That is a kind of broad protocol. And here we are sending some specific messages, and that will be sent. And some specific actions taken when message is received or other events in terms of the computer protocol or network protocol. The computer is different from human being. Thus, that should be very strict because the computer is not smart enough like human body. Thus, we should send clear message based on this clear protocol. Thus, if we are considering the network protocol instead of this human protocol, this is more strict because machines that is not smart enough, they are not smart enough, machines rather than humans. We are dealing with machines. All communication activity in internet that is governed by protocols. Thus, this is the definition about the protocol. Protocol, this one is defining format and order of messages sent and received among network entities and actions taken on message transmission and receipt. We'll learn about this protocol later. In this slide, we are learning just a brief concept about this protocol to get the overall picture of the whole image about the computer network and internet. This is another example showing some analogous example. He's asking the time, and he's answering about that. Hi, and also he is answering hi, and got the time. Now the time is 2 o'clock. This is protocol, human protocol. If we are considering computer network protocol, then this computer is asking, but this one cannot ask immediately this one should set up connection first. Thus, this one is about the TCP protocol. This one is requesting TCP connection first. Then the server, this one is answering about some request. Then this one is receiving that request and responding to that response message. TCP connection response. After that, the connection is established. After that, the real message can be sent to this server. For example, you are trying to access some web page here. Then this one is sending some web page file to this client PC, or this one can be smartphone or notebook. It doesn't matter. Same concept. Okay, let's move to the next. Okay, this chapter is explain about the network edge. Edge means the end part of the network, the end system, access networks, and communication links. We'll learn about this terminology. Okay, this one is a closer look at network structure. Think about this mobile network, and this figure is same as we saw already in the previous chapter. Global Internet Service Provider, Regional Internet Service Provider, Home Network. This is institutional network, our university network. Network edge. This one is the end part of the network. There's hosts are there, client and the servers open in data center like this. Still, those are in network edge. And the access networks, physical media. We can use wired line like this. Also, we can use wireless Wi-Fi line here, Wi-Fi communication link, wireless links. Inside, we can say this one is network core part. This one is the interconnected routers. Routers are being used, and those are interconnected together to transfer that message and to receive that message from other distant remote server. And this is a kind of network. This is another network, and those networks are interconnected together. Thus, internet is called internet network of networks, like this. And let's look at a little more about these access networks and the physical media. This is access network, and what kind of physical media is being used here. Here we can see just radio signal, no line, no physical line. This is called wireless line. Wireless. How to connect end system to edge routers. Here you can see this is a router. This is a router. To send through this network infrastructure, we should send first our message to this access point, that is router. Thus, we should be able to be connected to here. Then how? In terms of the communication links. Think about your residential house, residential access network. You can use ADSL or cable. And think about our university, that is called institutional access network, and mobile access networks. We can use Wi-Fi also. Also, we can use fourth generation, fifth generation technology. And we should think about the bandwidth. Because you are very sensitive to this bandwidth, how fast, and that is shared or dedicated. Also, this wireless, think about our university also, that will be shared. Or think about your wired line in your apartment, then the wired line that is dedicated. If you are using ADSL line, that is dedicated ADSL line. If you are using your notebook or using Wi-Fi, then you are using shared media. This is dedicated line. This is shared radio signal. Shared radio channel is being used. This is called physical media, and we learn this concept later in detail about this. Okay, a little more about the access network. Okay, let's look at this digital subscriber line. Think about your ADSL. A means asymmetric digital subscriber line. This one is for that. Think about your house. This one is ADSL modem. Those telephone can be hooked up together like this computer. They are hooked up together. And if you are calling just simple voice call, that will be transferred like that. Using this telephone network, that is traditional telephone network. Later, internet was introduced, and that technology is being used to provide some business depending upon that internet service providing. These telephone companies, in that company, that is another business, internet service provider. Probably that is the main business at this moment, but long time ago, that is the new and small business long time ago, but it grows so rapidly. Those telephone companies, they are providing this service based on that infrastructure, that is telephone line and the switching devices, and this internet router, that devices are hooked up together. Thus this telephone company can provide this internet service. Here, this one is using single physical line, that is telephone line, traditional telephone line, and voice and data, computer network, that data, internet data, that they can be transmitted together, but at different frequencies over this dedicated line to this central office. This is DSL access multiplexer. Multiplexer, this one is separating, and many things are coming together here, many signals, and they are separated after that. And here this one is aggregating them together, that is called a multiplexer. This one is using existing telephone line to central office D-SLAM. This is called D-SLAM. And data over DSL phone line goes to internet, and the voice over DSL phone line, that signal will go to this telephone network. This is conventional, traditional telephone network. And below around 2.5 megabps upstream transmission rate, but this speed is being changed. Recently, over 100 or 50 megabps, 100 megabps, almost 1 gigabps, that is becoming possible. The communication speed, transmission rate, that is increased a lot. And if we are considering fifth generation, the service that is around 1 gigabps instead of these megabps, 10 megabps, we can enjoy a couple of 100 megabps speed even in our house. Okay, if we are considering another access network, if we are considering cable modem, then this one is using cable network. This is cable company, and this infrastructure is cable head-end devices here, and this one is being shared to many other households. This is called cable modem. This cable modem and ADSL, those are introduced at the early 1990s. After that is evolved a lot and rapidly. Here, FDM, based on that frequency division, the different channels provided. Different channels transmitted in different frequency bands, like this. This one is frequency range, and in different frequency, different video channel, different channels being serviced. Also in different channel, in different frequency range, the data and control signals are being transmitted. Even though we are using single coaxial cable line, in terms of frequency, we can use many different channels if we are dividing that frequency range into these small pieces. And this one is showing still cable network and a little more. And here, internet service provider, that the infrastructure is hooked up here to provide internet service. And another technology, this one is simply hybrid fiber coaxial. That means fiber and coaxial, those are combined together, and that is called hybrid. Thus, this acronym is HFC. There's this is using fiber and also cable, and those are being used together. Then this technology is called HFC. This one is asymmetric, up to 30 megabps up downstream transmission rate, and this one is old speed. Also, this one is evolved a lot. There's much more than that speed, but long time ago, this one is asymmetric, and that means still that is asymmetric. That means the speed, upstream speed and the downstream speed. This is downstream speed. Usually the downstream speed that is required more than this upstream transmission rate, and they are not symmetric. Thus that is called asymmetric. And the network of cable and the fiber attaches this home to the internet service provider router here. And these households, homes are sharing that access network, this single cable. And that's different from this DSL. This one is using dedicated individual digital subscriber line, telephone line, but this one is sharing together with other households. Here, in terms of the signal, data and the TV signal, those are transmitted at different frequencies. The frequency division multiplexing, that technology is important here, and that is over this shared cable distribution network. And this is cable modem termination system called cable head-end site here, and this is called CMTS. Acronym is CMTS. That is not important, and just for reference. Let's look at a little more in detail about this home network. This is a kind of access network. Still we are learning that. Okay, this one is wireless devices. Think about your smartphone and iPad or notebook, and this one is access point. Usually this one is provided by this internet service provider, and also this one is router symbol, and sometimes these functionalities are combined together, often combined in single box, and the internet service provider like SK broadband or KT, LG Plus, they are providing this one. And this one, if that we are here, if this one is using wired Ethernet line, then that is called wired Ethernet. And here we can use cable modem or ADSL modem, depending upon their infrastructure of that internet service provider. Which you are subscribing. And this one is larger access network called enterprise access network, like our institutional network. This one is the Ethernet switch, and after that this one is a router. Usually our computer lab in our building, lecture room, we are using these switches, and many computers are hooked up together, around over 40, and this one is connected to the router. And this one is institutional link to internet service provider, and this one is institutional router, our university router, and this one is called Ethernet switch. And somewhere in our university, the web servers and the institutional mail servers, those are also DNS servers are there, and the internet service is being serviced. And typically this one is being used in companies, universities like that, or many other institutions. And the speed is a long time ago 10 megabps or 2 megabps. That was the speed, but after that 100 megabps over that, and 1 gigabps, usually 10 gigabps backbone link, and the transmission speed is being used. There's this end system, those are connected to this Ethernet switch, and we'll look at this Ethernet switch later, and we'll learn about this Ethernet switch and the router later. If we are considering wireless Wi-Fi, then that is called wireless access networks, shared wireless access network. Okay, I'll try to enlarge a little bit. Wireless access networks. This shared wireless access network that is connecting end system to router by a base station. this is called access point. This AKA means also known as. In other words, or base station or access point. This one is access point. Think about your house, apartment, and this one is provided by this internet service provider usually, and you are using that. And wireless LANs within building, this one is around 30 meter, and Wi-Fi, there may be different version, and 8.11, A, B, G, and so on, and depending upon that the version, the speed is a little bit different, like this. Think about your smartphone that is using Wi-Fi, also WAN, wireless area network technology, that is CDMA or fourth generation or fifth generation LTE, long-term evolution, WAN technology, mobile technology, and that is being still evolved. Fifth generation, that is being serviced first time in Korea in the world. This one is provided by a telephone company that is called telco, or cellular operator, and a couple of tens kilometer range, that is called wide area instead of the local area, that is called WAN, W-A-N, wide area network instead of local area network. And the speed is as you enjoy around or up to the 1 gigabps, thus a couple of 100 megabps speed you can enjoy with fifth generation LTE service. The still that is being evolved, and the sixth generation that is being discussed, and some standard work for future evolution that is being discussed. And let's look at this concept, host, that is terminology. This one is sending packets of data through the internet or computer network or communication links. Host is sending, and this one is sending packets through these communication links, and we should think about that packet length. And here we should think about the delay time. How long does it take to send this packet? The size is L bit. That will be depending upon the speed. That is called transmission rate. Simply we are dividing this size, packet size, into this rate, speed, then we can find out estimated packet transmission delay time. Here we are considering this unit. This unit is bit, and this one is divided by this bits per second. Finally, this one will go up, and this one will be eliminated together. Thus, this final unit will be second. That is delay time, packet transmission delay time. That unit is second. Okay, let's think about this physical media. There are many different kinds of physical media, and here let's look at this terminology, bit. This one is being transmitted between transmitter and receiver pairs, and bit is that electrical signal that is propagated, and through this physical link between this transmitter and receiver, physical link is there, And if we are considering the physical link, and if we are differentiating them depending upon the guidance, if that is guided, then that is called guided media, like this solid media, copper, fiber, coaxial. The signal is guided, and that is being transmitted through that guided media. And think about the Wi-Fi. You are using radio signal, and that is not guided. That is called unguided media. That is simply using the air, and that is being transmitted through the air in any direction. That is being transmitted and propagated freely. That is the radio. And think about this twisted pair line. Later I will show you it, their twisted pair cable. Here two insulated copper wires, and category 5, depending upon their speed and depending upon their electrical and the mechanical characteristics, that is a little bit different in terms of that electrical characteristic. Especially category 5, the speed is around 100 megabps and 1 gigabps Ethernet line. For that, this one can be used. But usually category 6, that is 10 gigabps, that is a little bit more expensive than this one, because that is providing the higher speed. And usually that is insulated, shielded. That means there's electrical noise that is immune to the electrical noise, thus it can be transmitted in higher speed in this category 6. And still we are learning the physical media, different media, coaxial cable and the fiber. Later I will show you this coaxial cable, also fiber. Usually in our offline lecture I circulated this real coaxial cable and the physical media of this fiber and Ethernet cable, and also we had the time to make that Ethernet cable, but unfortunately our lecture is online lecture. Thus, simply I will show in other lecture video. Coaxial cable, coax means same X. Same X, this one, this single thick copper wire. Usually we are using this one for our cable line to watch cable TV. Two concentric copper conductors and bidirectional broadband. Here single one, but outside is ground. And this one is bidirectional and broadband. That is, broadband means wide frequency range, and we can divide into very small pieces of frequency spectrum. Then we can provide a different channel. There's multiple channels, one single cable, that is possible. Think about our cable TV in our house. Even though we are using this single line cable, we can watch many different channels. If that is combined with the fiber, then that is called hybrid fiber coaxial. This is coaxial. Later, if that is combined in other area, then that is called HFC. Fiber optic cable, and usually that this glass fiber, and that technology, fiber optic cable, that is being evolved since 1970s, long time ago, around 1970s. You know the Corningware that is making some cooking dishes and cooking stuff, and usually based on glass, and that company started to make and manufacture very fine and pure glass fiber optic around the 1970s. At the year of 1970s, that was introduced in the world first time. And this one is carrying right pulses, and each pulse is a bit, and high-speed operation. Thus, that is very high speed, and also immune to any electromagnetic noise. The speed is here a couple of 100 gigabps or terabps speed. That is possible. And this is very low error rate. Thus, to transfer, to send to the long, far away, distant area, then the repeaters should be used. But when we are using the repeaters, that will be spaced far apart. Thus, that will be better and more economic, and also that is more immune to electromagnetic noise. Thus, even in the subway that is using high electric voltage, there may be electrical noise, but this fiber optic cable is installed there, and that is very immune. This one is probably the last slide in this subchapter 1.2 about this physical media. This one is finally introduced, radio. Here we are just using free air, and this signal is being transmitted freely through this air, and this one is radio signal. Signal carried in electromagnetic spectrum, no physical wire, and bidirectional. And propagation environment effects, this one is being reflected because that the signal, radio signal, is like light. That will be reflected, and obstruction by object, and there may be some interference. Thus, this one is not immune to the noise, and this is not strong enough in terms of noise immunity. Radio link type, there may be several different kinds. Terrestrial microwave, think about some FM radio station that is using, or TV radio station, terrestrial microwave signals are being transmitted. And LAN, think about this Wi-Fi. Depending upon the Wi-Fi, depending upon the version of that Wi-Fi, the speed will be different. And wide area network, LTE or cellular CDMA, the speed is also evolved a lot rapidly. There's a couple of hundred, approaching to 1 gigabps speed that is being possible in the fifth generation. And the satellite, if we are using satellite in the sky, usually that is 36,000 kilometers from the Earth, and geostationary orbit in the sky. That satellite is being used, like our Korea sat. The speed is like this. Also, they may be different from the technology evolution, depending upon that. But the delay time is around 270 milliseconds, end-to-end delay. That is so serious for real-time communication. Thus, this one is using geosynchronous, or if we are using low altitude satellite, then that is different, and the delay time will be different. But anyhow, for Korea sat, if we are using geosynchronous orbit, then the end-to-end delay time is like that.